Hello and welcome to this lesson on lifecycle assessments. In today's lesson, we will introduce what a lifecycle assessment is, understanding the purpose and importance of conducting lifecycle assessments, or LCAs. We will then identify and describe the stages involved in an LCA. So far, we've discussed how the use of natural resources affects the environment and the importance of sustainable resource management. Building on this foundation, LCAs allow us to systematically analyze the environmental impact of a product throughout its life. Let's get started. A life cycle assessment, or LCA, is a scientific method used to evaluate the environmental impacts associated with every stage of a product's life, from the extraction of raw materials to production, usage, and finally, disposal. The main purpose of conducting an LCA is to identify and quantify the environmental burdens during each stage and to evaluate opportunities for improving the environmental performance of products. By understanding LCAs, we can make informed decisions that help to minimize the negative effects on the environment. Let's break down the stages involved in an LCA and examine the environmental impacts at each step. Stage 1. Raw material extraction. The first stage involves extracting raw materials through mining, harvesting, or other means. This stage can have significant environmental impacts, including depletion of natural resources. Removing raw materials from the earth reduces the availability of those resources for future use. Habitat destruction. Mining and harvesting can destroy natural habitats, leading to loss of biodiversity. Energy consumption. Extraction. Processes often require large amounts of energy, contributing to greenhouse gas emissions. Finally, pollution. Extracting materials can lead to pollution, affecting both water quality and air quality. For example, extracting bauxite to produce aluminium requires clearing vegetation, which leads to habitat loss for plants and animals. Mining operations can also pollute nearby water sources, damaging local ecosystems. Stage 2. Processing, manufacturing, and packaging. In this stage, raw materials are converted into finished products. The environmental impacts at this point include energy use and emissions. Manufacturing processes require significant amounts of energy, often resulting in emissions of greenhouse gases. Waste generation. The production process can generate a substantial amount of waste, some of which may be harmful to the environment. Chemical usage. Manufacturing often involves chemicals that may release pollutants into the air or water. Packaging materials. Packaging is another source of environmental burden, contributing to waste if not properly managed. For instance, manufacturing plastic bottles involves not only energy use, but also the utilization of chemicals that can emit harmful pollutants. Stage 3. Transport and distribution. Transportation occurs throughout a product's entire life cycle, from moving raw materials to distributing finished goods and eventually transporting waste for disposal. The impacts of transportation include fuel consumption. Transporting products requires fuel, leading to energy use and greenhouse gas emissions. Air pollution. Vehicle exhaust contributes to air pollution. Traffic-related impacts. The logistics involved can also add to congestion and its associated environmental effects. For instance, transporting raw metals from mining sites to processing facilities and then to manufacturers adds to the overall carbon footprint of the product. Stage 4. Use and operation during its lifetime. The third stage assesses the impact of the product while it is being used by consumers. The key impacts include energy consumption. Products like electrical appliances consume energy during their use, contributing to greenhouse gas emissions. Emissions. Some products, such as vehicles, emit pollutants while being used. Resource use. Products may require additional resources during their use, such as water in the case of a washing machine. Take the example of a washing machine. Throughout its life, it consumes both water and electricity, which contributes to resource depletion and increased emissions. Finally, we have end-of-life disposal. When a product reaches the end of its useful life, it needs to be disposed of. This stage can have multiple environmental impacts, such as landfill space usage. Many products end up in landfills, taking up valuable space and contributing to pollution. Emissions from incineration. If products are incinerated, they can release harmful gases into the atmosphere. Potential for recycling. Recycling materials can help reduce the need for extracting new raw materials and minimize environmental impacts. Toxic substances. If not disposed of properly, certain products like electronic waste can release toxic substances into the environment. For example, old electronic devices can release harmful substances if not recycled, contaminating soil and water sources. Visualizing an LCA can be helpful. Imagine the life of a product as a journey with multiple stages, each contributing to the overall environmental footprint. By analyzing and optimizing each stage, we can work towards reducing the cumulative impact of the product on the environment. In today's lesson, we delved into lifecycle assessments to understand their purpose and importance in evaluating the environmental impact of products from their creation to disposal. By analyzing each stage, LCAs provide a comprehensive view of the environmental impacts of a product's lifecycle. Understanding these impacts allows businesses and consumers to make more sustainable choices, such as selecting materials with lower environmental footprints, improving manufacturing efficiency, or opting for products with longer lifespans and better end-of-life disposal options. Watch the rest of the GCSE chemistry course at Sophos Education.